So again, we're just looking at a couple problems from 9.5, but I'm reviewing. These are two formulas we learned in 9.4. We're actually going to review these two today in what we do in 9.5, but it's all just formula stuff. Don't overthink it. I'm not going to do anything too crazy. So we can do way more with this stuff. We're doing very basic stuff, types of problems that you've seen on here. I'm going to go down to 9.5 now, and I'm looking at number 3 in 9.5. So we skipped a lot of problems. Look how many problems we skipped. Lots of problems. So we are at number 3, and it says find the sum. When it says find the sum, you're going to use one of these formulas. These all start with S sub n because S means sum. When it's an arithmetic, oh God, I'm sure I spelled that really wrong. Whatever, abbreviated there. When it's an arithmetic sequence, that means you're adding or subtracting to get to the next term. Your sum of that will be n divided by 2 times a sub 1 times or plus a sub n. N, remember, means the number of terms that we have. So it's like 2 terms or 20 terms or 50,000 terms. A sub n is your first term, and a sub 1 is your first, and then a sub n is just whatever the nth term is. The 8th term, the 20th term, the 52nd term, I don't care what it is. For geometric, remember geometric is when you multiply or divide. That formula goes S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. A sub 1 is the exact same thing in both of these. It's just the first term in your sequence. N is the exact same thing too. It's the number of terms that we have. The only different thing I have in this formula that I don't have in the other one is R, which is your common ratio. It's what you multiplied or divided by in order to get to the next term. Multiplied by 2, then your R is 2. Divided by 3, then your R is 1/3. So it's just whatever you are multiplying or dividing by. And then the last one, we're just going to do one example like this, and I will literally say in the directions, find the infinite sum. And that formula goes S sub n equals a sub 1 over 1 minus r. Again, you do not have to know these. I'm going to give them to you. Hi, Troy. Thanks. I'm going to give these to you. Okay, let's do a couple examples so we can find this. Okay, finding the sum is just adding up all the terms in a sequence together. So like if I give you a full sequence and I say find the sum, you could literally just add that together in your calculator. However, I'm going to argue sometimes I'm not going to give you the full sum. Like in this one, I'm going to give you ... That means that there's numbers in between 103 and 33. So we need to take note of that. And we have to either find all those missing terms and add them together or use the formula I'm giving you. So we're going to do letter A 2 ways. One is a bootleg way if you have no idea what else to do. If it says find the sum, just add them together, right? Get my little calculator out. I'm just going to add all those numbers together. -7 plus -3 plus 1 plus 5 plus 9. That's, oh, plus 13. So that last class too. That's 18. So if you knew nothing else and you just were like, oh, I'm going to find the sum, I'm just going to add them all together. Add them all up. Equals 18. Okay. Now, what I would rather just do is use one of the formulas, because especially if I don't list all the numbers for you, it's easy to just plug and chug in a formula. Is this sequence arithmetic or geometric? Am I adding and subtracting to get to the next term? Or am I multiplying or dividing to get to the next term? If you have no idea what's happening, I just literally told you. Arithmetic means you add or subtract to get to the next term. Geometric means you're dividing or multiplying. What are you doing to get from -7 to -3? Adding. What number am I adding? 4. You could go to anywhere in this sequence. 5 to 9 is a really easy thing to see that you added 4. 1 to 5 is. -7 to 3. Every single time you're just adding 4. So that means it's arithmetic. That means I'm going to use the first formula that is labeled arithmetic, and I'm going to plug those things in. Okay, let me write it down there, and then I'm going to plug it in. So I've got S sub n equals n over 2 times n, or a sub 1 plus a sub n. I just told you that n is the number of terms. How many numbers do you see in that sequence? 1, 2, 3, 4, 5, 6. Very good. So instead of n, I'm going to write 6. I'm just erasing because I literally have it on the slide, like over on the slide. I just can't show you all of that. A sub 1 is your first term. What's the first term in this list? Perfect. And then a sub n is the last term, or the nth term, and the last term here is 13. So I'm going to do 6 divided by 2 times -7 plus 13. 6 divided by 2 is 3. -7 plus 13 is 6. 3 times 6 is 18. And that is proving that's the same number I got when I just simply added them all up. I'm just proving that this works. Now, for letter B, you could do what we did in letter A, but you have to find all the terms that are missing between 103 and 33. Is this arithmetic or geometric? Am I adding or subtracting or multiplying or dividing to get to the next term? Arithmetic, good. What am I adding or subtracting? -7. So it's arithmetic. So that means I'm using the same formula I did before. My common difference is that -7. That's what you're doing between each term to get to the other one. Now, what you could do is just find all the other terms in this. You can go 103 and then -7 and write that number down, and then -7 and write that number down, and -7 and -7 and -7 until you get to 33. And then you can add all those numbers up. But again, I think that's a little bit time consuming. And so like what I would rather do is use my formula. So I've got S sub n equals n over 2 times a sub 1 plus a sub n. I have my a sub 1 and I have my a sub n. What I don't have though is my n. And this is actually helpful because it's going to review what maybe you missed in the last lesson right now to help us find n. If we're going to find n, we're going to use one of those formulas I showed you right at the very beginning of class. We're using the one that goes a sub n equals a sub 1 plus n minus 1 times d. At the beginning of class, I told you that can help you find like the 12th term. It can help you find the first term. It can help you find the common difference. What we're going to use it for right now is to help us find n. It's just a formula with 4 variables. So as long as you have 3 pieces of information, you can find whichever 4th piece you need. In this case, I know that my a sub n, or my last term, is 33. I know that my first term, a sub 1, is 117. I don't know n, but I do know d is -7. Now we just have an algebra 1 equation, and we're going to solve that for n. So I'm going to distribute that -7. I'm also going to minus that 117 from both sides. So 33 minus 117 is going to be -84 equals -7n plus 7. Minus 7 from both sides, get -7n by itself. And then I'm going to divide by -7. Oh, there's a lot of -7s there. But my d means common difference. That's what you do to get from one term to the next term. And so once I solved that all out, I found that n, or the number of terms I have, 33, is the 13th term. So if I were to list them all out, once I got to spot 13, that should be the number 33. The reason I needed to do that is now I have the n to plug into that first equation that I started to plug into, but then had to pause because I didn't have enough info. So I'm going to go plug n, take n out and put 13 in there, and I'm going to solve that. Now these are all sums. Sums are going to be pretty big numbers. So if you get some kind of weird big number, don't let that panic you. That's fine. We're going to get kind of a weird number. So I've got 117 plus 33. I'm going to multiply that by 13, and I'm going to divide that by 2, and I get 975. That's the sum of all those numbers if I were to add them all together. okay? We're gonna do this exact same process, but with the geometric one. So that's gonna practice some more geometric sequences in series. You guys ready to go? Let's go to the next one. Next one's letter C, and it says 5, 15, 45. By just looking at that, I know that it's geometric because I know that I have to be multiplying something to get really big that fast, right? It would take forever if I was just adding something to get to 98,000, blah, blah, blah. So I'm multiplying by 3 here. Now remember, and I don't know why we choose to do this, but when we are in the geometric world, we say R equals instead of D equals. So difference is like, how do you get from one term to the next by adding or subtracting? R means common ratio. You can call them both D or both R if that doesn't matter to you. So, okay. Again, I'm going to use my S of N formula. We haven't used this one yet. It's this geometric one, which again, I will have nicely labeled so you know what's going on. I'm going to take this down. Okay, it says S of N equals A sub 1 times 1 minus R to the N over 1 minus R. Same thing as before, we have everything but N. I can plug 5 in for my A sub 1. I can plug 3 in for my R in both places, but I don't have an N, so I need to go and figure that out. I'm going to do the same process as I did last time, but since it's geometric, it's a different formula. So let's practice that. This formula here, and again, I'll have these written down. A sub N equals A sub 1 times R raised to the N minus 1. I'm asking you guys to know a lot of things. I totally recognize that. So I'm going to give you as much as I can. I'll give you all of these formulas. I can give you Pascal's triangle, but I think that's really all I can give you. Everything else, there's no formula for. Okay, so I'm going to plug this in. I'm going to find R. A sub N, my last term is this guy, 98,415. A sub 1 was 5. I don't know R. No, I do know R. Excuse me. I do know R is 3, but I don't know N. I'm going to solve this by getting rid of the 5. So divide by 5 on both sides. So 98,415 divided by 5 is going to be 19,683 equals 3 raised to the N minus 1. Now this takes us back to chapter 3, which was logs and exponentials. I'm sure you're like, oh God, Miss White, I don't remember anything there. Even if you have to take the final, logs and exponentials will not be on that. Luckily, Mrs. Ford did all of that before the semester break happened, and I know we did a lot this semester, but since she didn't, we're not having that on the final, so you don't have to relearn that. A bootleg way of finding this out is I know that this has to be 3 raised to some power. We're just going to guess and check to find that. Remember, use your tool belt. If you remember logs, go for it. Use it. I would bet money none of us remember logs. I don't mean that meanly. I barely remember logs. It's just because I teach it. I got to remind myself every so often. So I'm going to go to my calculator. I'm going to start doing 3 raised to some power and figure out what 3 raised to which power is that 19,000. It's probably going to be a big number, right? Let's start with like 7. Ooh, 3 raised to the 7th is 2,000 something. Okay, I need it even bigger. Try 3 raised to the 8th. Everyone know that I'm just guessing and checking. There's nowhere that these numbers came from. I'm just making them up. Okay, this is still not there yet. Let's try 3 to the 9th. Oh, perfect. So this is the same thing as 3 to the 9th. Now, one exponential thing I think you should remember, because it's about to make this problem so easy, is I have 3 to the 9th equals 3 to the N minus 1. I have the same base, so that means that my exponents must equal each other. So 9 equals N minus 1. So what's my N? What number terms do I have here? 10. And I did all that work out because I want to plug that into my formula. So now I'm going back to that green formula. I'm going to do 5 times 1 minus 3 raised to the 10th. And I'm going to divide that by -2 momentarily. 1 minus 3 is -2, so I'm dividing that huge number by -2. And you see what I'm talking about? These sums are going to be huge numbers. This is 147,620. You might think there's no way that number can be that big. Yes, way, because I'm adding up all these numbers, and one of those numbers is 96,000. It's going to be a huge number. All right, I think I just want to do one more problem. And then I want you to just do some work and see what you know and what you don't know. Cool? Okay, the last thing I want to do, I want to skip number 4, and I'm going to come down here and say, find the sum of the infinite series. So it says infinite series. Remember before I gave you a formula that said infinite series? That's what we're using here. S of n equals a sub 1 over 1 minus r. This is a series that goes on and on and on and on and on forever. It doesn't stop. So it's not like the other terms where we're like, oh, you're finding the sum of the first 20 terms or the first 50 terms or the first 3 terms. We're finding the sum of all of these terms. Now, the only reason this works is because this series converges down to a certain number. So it's going to get closer and closer to a certain number here. That's why we're able to add them up and find out what the sum is, even though it's an infinite amount of numbers, it's still going to get closer and closer to one number. So we're going to plug it in. I've got S of n equals a sub 1 is 3 over 1 minus my rate, or my common ratio. I'm multiplying by 1/2, right? So minus 1/2. I get 3 over -1/2. Oh no, it's positive 1/2. Man, why did last period let me write -1/2? That's so stupid. 1 minus 1/2 is a positive 1/2. That's so dumb. Okay. And then 3 divided by 1/2 is the same thing as 3 times 2 over 1. So my sum of this series equals 6. Okay, that's it. A lot of these formula stuff is just simple plug and chug. And if you look at your study guide, it's the second side of the study guide that looks, it's a CUDA worksheet. It like is not the like handwritten ones or the typed up ones out. The sheet that looks like this is 4, 5, 4, 4, 4, 9, 4, 5, 5. This back side, the second side of your study guide, is all factors on the 9, 4, 9, 5 stuff. The other stuff is mostly 9, 1, 9, 3. The only thing I didn't do a good job of putting on here was the Venn diagram. So let's look at what's fair game. We did not do a lot. So if you are behind on notes, I suggest watching the video or getting caught up, because there's a lot you don't have to know how to do. So like we didn't do anything past like this number 5. So like I will not ask you to write the fraction in the lowest terms. I will not do any word problems back here. Question. We did very minimal summation notation, which is where I gave it to you and you had to plug it in. I will not ask you to write it. So ones like letter A are fair game. The Venn diagram stuff that I want to show you is we did ones where we had, like I gave you a Venn diagram and you had to read it, and then where we made 3 from it. I will not ask you to do ones where it's like probability of A and B or A or B. I will not ask you to do anything like this, number 8 or 9. You spend the whole college courses on probability, so I can only sub so much in a couple of weeks. So that is just not that important. Right, any questions for the good of the group? All right. 9-4 is those formulas. So the types of problems that we did are all fair game. I would look at ones where I said, like write the explicit formula. So if I give you a little sequence, can you write the formula from it? Can you also find like the 10th term or the 20th term? I will not ask you this recursive problem. So I know we did one like this, but I will not put that on there. There's so many other things I need you to learn. You don't have to worry about that. And this number 5 is a lot like what I was just talking about on number 3. So this is also true. Ones like this one, find the first term of, that's like more like a bonus problem. That's fair game. You should know how to do those. Okay, cool. Well, I'm going to shut up for a little bit. If you want me to come and help you, I'd be happy to. If you want to do work on your own, great. This is the last thing everybody has to do for me. If you're behind on anything, let's try and get that made up ASAP because we're in like limited crunch time. Cool. All right. I'm going to stop this record.